Hello everyone, welcome. So today I will be discussing about real numbers which is there. So this real numbers, that would mean that I am talking about the complete number line. So when I'm talking about the complete number line, we would have already studied earlier that when I included say numbers like 1, 2, 3, 4, 5, all this I put it in the form of natural numbers. So I told it as natural numbers. When I included 0, 1, 2, 3, 4, 5, I called it as whole number. I called it as whole number because of 0. Then when I started including along with 0, 1, 2, 3, 4, 5, I started including -1, -2, -3. I call this as integers. I call this as integers. Now between 1 and 2, we told that there can be numbers like 1 by 2, 3 by 19, all these numbers. So numbers in the form p by q. So this I called it as fractions. And when I took about the negative parts of fractions, I called this as, putting this together, I called it as rational numbers. I called it as rational numbers. Now the whole of the set put together, okay, I call it as real numbers. These are real numbers. So when I say real numbers, they are nothing but they are in the form p by q where q is not equal to 0. So because I can write a number like 64, which is a whole number, I can write 64 by 1. I can write any number. I can write -32 by 1. It is valid, it is equal to -32. So all these are valid examples that we have. So this is what I call it as real numbers. Now, when we again talk about real numbers, this is one thing that we have. I can express any real number that we have in the form of fractions or in the form of their factors, their composite factors. I can take any real number, I can tell them in the form of their factors. Say I take every composite number can be expressed or factorized as a product of prime, and this factorization is unique apart from the order in which the prime factors occur. So there are prime factors. So if I take one question as 34, then when I factorize 34, so how will I factorize 34? When I factorize 34, I will first divide it by 2. So when I divide it by 2, I will get something as 17. Okay, so now 17 is again a prime factor. So I can write the number as 2 into 17. I can take another number. Say I take another number 58. I prime factorize 58 means I will divide it by 2. So 2 to the 4, 9 to the 18. Again, I can write 58 as 2 into 29. So I can always have a prime factors for the numbers. Now, when I factorize, there is something I should learn or I should know. So, what is that? That is known as test of divisibility. So, test of divisibility. So, when I talk about test of divisibility, there are various tests. Now, what is this test of divisibility will say? Test of divisibility will say whether a given number is divisible by which all prime numbers. Okay, so now we have got few tests of divisibility. Now test of divisibility by 2. So if a number has to be divisible by 2, then what are the things? The last digit, that is the digit over here, the ones place, it has to be 0, 2, 4, 6, 8. So it has to be an even number. It has to be an even number. Now, if I have to do the test of divisibility by 3, then what is it? The sum of digits should be divisible by 3. You can make a note of this. Sum of digits should be divisible by 3. Next prime number is 5. So the last digit should be 0 or 5. Then divisibility by 7. Divisibility by 7, if I take a number which is divisible by 7, then what will I do? I will have to take out the last digit, multiply the last digit by, let us take 343. So I am taking this last digit, multiply the last digit with 2. Okay, and I will have to minus that from here. Okay, so I am getting 28. So this is divisible by 7. Hence, this number is divisible by 7. Okay. Next, divisibility by 11. If I take the even digits minus the odd places, sum of the digits in odd places, minus it, then if it comes 0 or 11, I will get the number as divisible by 11. Say 1, 3, 4, 3, 1. So odd digits, let me put it. So 1 plus 4 plus 1. So 1 plus 4 plus 1 is 6. Now what is 3 plus 3? 3 plus 3 is equal to 6. Now I will minus this. If I get 0 or 11, then it is divisible by 11. Hence this is divisible by 11. So these are the test of divisibility. When I go ahead with the questions, I will keep on talking about this divisibility so that it gets clear to you more further. This is just a revision. We have learned this long back. So herein, if we try ahead solving few questions. So the question says express each numbers as a product of its prime factors. So first question is 100 and first question is 140. So if I have to prime factorize, when I prime factorize, what is the last digit here? Is 0. Hence I told it will be divisible by 2. So if I divide 2, 140, what will I get? 7 2s are 14 and 0 goes here. So it will be 70. Again 0 at the end, so it is again divisible by 2. Hence I'll get 3 2s are 6, 1 remainder 10, 5 2s are 10. Now it is no more divisible by 2. To check divisibility by 3, 3 plus 5 is 8. 8 is not divisible by 3, hence 35 is not divisible by 3. Next, n digit is 5, hence it is divisible by 5. 7 5s are 35. So I can write 140 is equal to 2 into 2 into 5 into 7. Okay. Now, next question. I have 156. Now 156, if I have to divide it by 6 is again, 6 is a even number, hence 156 divisible by 2. So first I'll divide it by 2. 2. What will I have? 7 2s are 14. Carry over 1. So 8 2s are 16. Again here divisible by 2. 3 2s are 6. Carry 1 7. 8 9 2s are 18. Then 39 divisible by 3. 9 plus 3 is 12. Divisible by 3. So 3 13. 13 is a prime number. So 156 can be written as 2 into 2 into 3 into 13. Now next question, if I take it up, next question is 3825. Next question is 3825. Now I will again divide. It is not divisible by 2. To find it divisible by 3, I have to add the digits. 8 plus 3, 11. 11 plus 2, 13. 13 plus 5, 18. So it is divisible by 3, 3. So 3 ones are 3, 3 twos are 6, 22, 7 threes are 21, 5 threes are 50. Again this number is divisible by 3, 4 threes are 12, 3 twos are 6, 5 threes are 15. Now it is divisible, no more divisible by 3. So now I'll divide it by 5. 5, 8 5s are 40, 5 5s are 25. Again 5, 5 1s are 5, 35, 7 5s are 35. So I can write 3825 as 3 into 3 into 5 into 5 into 70. Now coming to the next question, I have 5005. This I can divide it by 51001. Okay. Now so it is no more divisible by 5. Now to divisible by 7, how will I say? 100 minus 2. What is it? 298. So 98 is divisible by 7, right? So now in this case, what will I do? 7, 7 ones are 7, 30, 7 fours are 28, 21, 7 threes are 21. Now it is not divisible by 7. Now I'll try divisible by 11. 11 ones are 11, threes are 30. So 5005 is equal to 5 into 7 into 11 into 30. Right? Similarly, 7429 remains for you for a practice. Okay? Thank you.